Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope you guys are doing great, having a good time, yeah. So people, let me know fast in the chat box first if I'm audible and visible to everyone, right? Let me know people in the chat box if I'm audible and visible to every single guy. Let me know fast in the chat box people. Yes, I'm better than before. Hello Arjumand, hello Ashwani, hello Shadab. Hello Asif, hello Shiva, hi Prashant, hello Mahak, hello Arshad. Welcome back people, welcome back. Hello Ashwarya, hello Farooq. Welcome back my dear elites. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you. Yeah, then we'll be starting the session directly. Karthik, I'm better than before bro. So people, just let me know in the chat box fast. Let me know in the chat box fast if I'm audible and visible to every single guy, yeah? Perfect people, perfect. So as you all must be knowing, tonight what we are going to do is, we are going to do the top-notch 100 questions from the chapter Equilibrium, right? Yes, and before starting the session, the ones who are new to the channel, let me introduce myself first. My name is Wassim and I'm your chemistry master teacher writer on this NEET Elite channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, right people? Welcome back everyone, welcome back. Yes, top notch 100 questions from hydrocarbons will be also done, just wait for it. Let's complete the equilibrium first. After that, we'll be doing that as well. Walaikum salam, Sanifa. Perfect, people. So, you guys can let me know in the chat box if you are super duper excited about the tonight's session as well. Let me know, people, fast in the chat box if you are super duper excited for the tonight's session as well, right? Let me know in the chat box. Let me know in the chat box fast. Perfect, people. Perfect. Wonderful. So let's get going then. Let's get started with the NEET 2021 top-notch 100 questions from the Chemical and Ionic Equilibrium, right? With the first question, which is going to be on your screen in 3, 2, 1, and now. Well, people, this is the first question. Just give it a try. Let me know the answer of this question. Okay, this is the first set of question, first pattern of question which can be asked in your NEET 2021, right? Well, as you can see, I'm given with two reactions. N2 plus O2 is in equilibrium with 2 times NO. This is the first reaction, right? And the second reaction is NO in equilibrium with half of N2 plus half of O2, right? Well, as per the question is concerned, K1 and K2 are the equilibrium constants for the reaction first and 2. That means the equilibrium constant for the first reaction is K1. The equilibrium constant for the second reaction is K2. What do I need to check? I need to check the relation between K1 and K2. That's it, right? I need to check the relation between K1 and K2. Now, people, how will I be checking it, right? Let's try to check it out. See, if you look at the second reaction, just have a look on the second reaction. First of all, what I'll be doing is, I'll be just reversing the second reaction, right? If I'll reverse the second reaction, it becomes half of N2 plus half of O2 in equilibrium with NO gas, right? And you all must be knowing, whenever we reverse the reaction, its equilibrium constant is inversed. So new equilibrium constant for this reaction becomes 1 by K2 because I have reversed the reaction. Point number 1. Now people, after reversing the reaction, I'll be multiplying the same reaction, this one, by 2, right? If I multiply this reaction by 2, it becomes N2 plus O2 in equilibrium with 2 times NO, correct? And you all must be familiar with the fact, whenever we multiply any reaction by certain number, that number goes to the power of equilibrium constant. So I'll say the new equilibrium constant for this reaction is going to be 1 by K2 raised to the power 2, right? Now just compare these two reactions. I'll say these two reactions are same, correct? So this term should be equal to what? This term should be equal to K1. So this is the relation between K1 and K2 which I was supposed to calculate. So I got to know K1 is equal to 1 by K2 ka square. So option A is the one which is correct among all, right? Yes, people, a very simple question this is. Chandu, this is not the mentee session. This is not the mentee, it's a normal session, right? It is the question answer session, that's it. It's not the mentee session, right? Well, people, the first question, very simple and basic it was, right? Moving on to one more similar type of question. You guys can solve it and let me know its answer fast. And people, I'll be a little fast in the today's session. Why? Because right after this session, I've got one more session on Vedantu JEE English channel as well, right? Okay, so I'll try to complete the questions in lesser time, okay? Okay, have a look, guys. The equilibrium constant for the reversible reaction. Okay, I'm given with the reaction N2 plus 3 times H2 in equilibrium with 2 times NH3. Its equilibrium constant is K. One more reaction is given to us. The equilibrium constant for this reaction, for the second reaction, is K dash. I need to see the relation between K and K dash, right? I need to see the relation, right? Now we will have a look. It's again a similar type of question. See, look at the second reaction, people. Look at the second reaction. If you multiply second reaction by 2, the reaction becomes N2 plus 3 times H2 in equilibrium with 2 times NH3, right? What I did simply, I multiplied the second reaction by 2, and that 2 will be going to the power of its equilibrium constant. So its new equilibrium constant is going to be K dash square, right? Well, if you look at this reaction and this reaction, they are same, correct? So you can clearly say K dash square is equal to K. This is the relation between K and K dash. Again, a very simple question this was, right? Or you can clearly say K dash is equal to under root of K, correct? I believe that is the option C. Option C must be the correct answer of this question, right? A very simple question again this was. Perfect. I'll be moving on to one more question directly. This is one more question, people. Again, a very, very simple question. Again, a very, very simple question, right? See, guys, how this sort of a question is to be solved. Well, first of all, the reaction that's given to me, that is 2A in equilibrium with B plus C, right? 2A in equilibrium with B plus C. This is the reaction that's given to me. The equilibrium concentration of A, B, and C are given, right? I'm given with the concentration of A at equilibrium. I'm given with the concentration of B at equilibrium, and I'm given with the concentration of C at equilibrium as well, right? All the equilibrium concentrations of reactants and products are given to me. I'll be simply writing the expression of Kc equilibrium constant. That's going to be concentration of B at equilibrium raised to the power, its stoichiometric coefficient, that's 1, multiplied by concentration of C at equilibrium raised to the power 1, divided by concentration of A at equilibrium raised to the power 2. Right? Well, people, all these parameters are given to me. You need to put the values of all these parameters into this equation. You'll be getting the value of equilibrium constant, which I was supposed to calculate, right? See, equilibrium concentration of A is given, B is given, as well as C is given, right? All these parameters are given. Just put the values into this equation, get the value of Kc. Well, I can see majority of the people are coming up with option B. So option B must be the answer of the equation, right? A very simpler one. A very simpler one, right? Right, people? Correct? Let me move on to one more question. This is one more question, right? Okay. See, guys, how this sort of a question is to be solved. We have got a reaction. We have got a reaction A plus B in equilibrium with C plus D, right? This is the reaction that's given to me. Initially, we start with equal concentration of A and B. So initially, I'm starting with the equal concentration of A and B. At equilibrium, we find that the moles of C is 2 times that of A, okay? At equilibrium, it is seen that moles of C is 2 times that of moles of A. See, guys, it's seen that at equilibrium, moles of C is 2 times that of moles of A. Let's assume moles of A at equilibrium is X. That means moles of B at equilibrium will be also X, right? Moles of C at equilibrium will be 2 times X, and moles of D at equilibrium will be again 2 times X. Right? Because everything is mentioned in the equation. Initially, you are starting with the equal concentrations of A and B, right? And at equilibrium, what you are saying the moles of C is equal to 2 times that of moles of A. That means the moles of D will be also 2 times that of moles of A, right? Now, you got everything. Just write the expression for equilibrium constant. It's going to be concentration of C at equilibrium raised by stoichiometric coefficient, concentration of D at equilibrium raised by stoichiometric coefficient, divided by concentration of A at equilibrium raised by stoichiometric coefficient, concentration of B at equilibrium raised by stoichiometric coefficient, right? So it's going to be 2x multiplied by 2x, right? 2x multiplied by 2x divided by what? Divided by x multiplied by x. So this x square got cancelled. The value came out to be 4, and it's going to be option C, which is the correct answer of the equation. I'm sure it's again clear to you, right? Right, people? I'm sure it's clear to you. It's a very simple question. Just read the question carefully and kill it, right? Exactly. All of you have given the correct answer. It's going to be option C. Right, people? Okay. Let's move on to one more question then. One more similar type of question, and you can kill it. Trust me on that, yeah? You can solve it properly. What do I need to do? I need to get the relation between K1 and K2. I need to get the relation between K1 and K2, right? So, what kind of relation I'll be getting? Understand properly what I'll be doing, right? See, first of all, let me reverse the first reaction. It becomes 2 times AB in equilibrium with A2 plus B2. And we know on reversing the reaction, equilibrium constant is inversed. So the new equilibrium constant of this reaction becomes 1 by K1, right? Now, people, if I multiply this reaction by 3, I'm multiplying this reaction by 3. It becomes 6 times AB in equilibrium with 3 times A2 plus what? Plus 3 times B2 as well, correct? Yes. I have multiplied this reaction by 3, and that 3 is going to be the power of this equilibrium constant, 1 by K1 raised power 3, right? Now, people, just have a look on this equation and have a look on this equation as well. Both are same, so I must say K2 is equal to 1 divided by K1 raised power 3, right? So what is going to be the answer of this question? K2 is equal to K1 raised power minus 3, right? So option C is the one which is correct among all. I'm sure it's clear to everyone again, right? Welcome back, everyone. Welcome back. A very simple question again, right? Okay, moving on to one more question, guys. If the value of an equilibrium constant for a particular reaction is 1.6 into 10 raised power 12, then at equilibrium, the system will contain mostly reactants, mostly products, a similar amount of reactants and products, all reactants. What do you think about this one? See, guys, the value of equilibrium constant. See, guys, for example, I have got the reaction like this: A in equilibrium with B, where A is the reactant, B is the product. A is the reactant, B is the product, right? Yes. Now, people, equilibrium constant of this reaction I'm writing as concentration of product at equilibrium divided by concentration of reactant at equilibrium. Yes. Now, this equilibrium constant for the reaction, it's given to me as 1.6 into 10 raised power 12, right? So, people, have a look on this properly. This value is pretty much large, right? This value is pretty much large, correct? As you can see, it's 10 raised power 12 something. This value is pretty much large. This value will be only large if this numerator is large and denominator is less. Numerator is large, that means concentration of product is more. Right? The question is done. So what is going to be the answer of this question? Option B, yeah? Simple question. Absolutely, guys, absolutely. Let's move on to one more question then. It was a very simple one, right? Okay, given that the equilibrium constant for the reaction, this at a particular temperature something, yes? What is the value of the equilibrium constant for the following reaction? Again, the similar sort of question, guys. Again, the similar sort. And this is the previous equation as well. Okay? Well, people, given that the equilibrium constant for this reaction, I'm given with the equilibrium constant of this reaction as 278, right? What is the value of equilibrium constant for the following reaction? I need to get the equilibrium constant of this reaction. Okay, how will I be doing it? See, first of all, let me reverse the first reaction. If I reverse the first reaction, it becomes 2 times SO3 in equilibrium with 2 times SO2 plus O2, right? Since I've reversed the reaction, so its equilibrium constant will be inversed. So its new equilibrium constant is going to be 1 divided by 278, correct? I've reversed the reaction. Now, after reversing the reaction, let me multiply this reaction by 1 by 2. If I multiply this reaction by 1 by 2, it becomes SO3 in equilibrium with SO2 plus half of O2, correct? Since I have multiplied this reaction by 1 by 2, so that 1 by 2 will be going to the power of equilibrium constant. It's going to be 1 by 278 raised power 1 by 2, correct? Right? So just look at this reaction and look at this reaction. They are same, correct? So you can clearly say the equilibrium constant of this reaction will be equal to under root of 1 divided by 278. Now you need to do a bit of calculation, get the answer over here. So finally, what do you get the answer over here? Finally, 1 divided by 278 ka root, it comes out to be 6 into 10 raised power minus 2. I'm sure it's again clear to you, right? Right, people? Yes, Ravan, I'll be doing that. Perfect. Let me move on to one more question then. Write the Kp expression for the following in terms of Kc. First of all, you all must be knowing about the fact Kp is equal to Kc RT raised to the power delta N. Correct? This is something which you all must be knowing. Now look at the first reaction, guys. Let's calculate delta N for the first reaction, which is going to be equal to number of moles of gaseous products minus number of moles of gaseous reactants, which is 1 plus 1, 2. So 2 minus 2 comes out to be 0. So for the first reaction, Kp is equal to Kc, right? What about the second reaction, guys? What about the second reaction? What is the value of delta N for the second reaction? It's going to be number of moles of gaseous products, 1 plus 1, 2, minus number of moles of gaseous reactants, that's 1. 2 minus 1 comes out to be 1. So you can clearly say Kp is equal to Kc RT raised to the power 1. This is the relation between Kp and Kc. Similarly, if you look at the third reaction, let's calculate delta N for the third reaction. It's going to be number of moles of gaseous products, which is 2, minus number of moles of gaseous reactants, which is 1 plus 3, 4. So the value comes out to be minus 2. So you can clearly say Kp is equal to Kc RT raised to the power delta N, which is minus 2. This is the relation. And look at the last one. See, for the last one, I can say delta N is going to be equal to number of moles of gaseous products, which is only 1, right? This in solid form, I've got nothing to do with this. This in solid form, I've got nothing to do with this, right? So you can clearly say Kp is equal to Kc multiplied by RT raised to the power 1. This is the relation between Kp and Kc for every reaction. I'm sure it's clear to everyone, right? Right, people? Right? And the ones who have just joined it, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Right, people? Moving on to one more question. Again, a similar type of question. In which of the following equilibrium Kc and Kp are not equal? First of all, what is the relation between Kp and Kc? We know Kp is equal to Kc RT raised to the power delta N. Correct? This is the general relation. This is the general relation, right? Now, people, when Kp will be equal to Kc? Kp will be equal to Kc only if delta Ng is equal to 0, right? Kp will be equal to Kc only if delta Ng is equal to 0. In which of the following Kc and Kp are not equal? That means Kp won't be equal to Kc if delta Ng is non-zero. Now you need to see in which of the reaction delta Ng is non-zero. That's going to be the answer. You need to see in which of the reaction delta Ng is non-zero. If you look at the last option, number of moles of gaseous products 2 minus number of moles of gaseous reactants 2 plus 1 3. So 2 minus 3 comes out to be minus 1. So delta Ng for this reaction comes out to be minus 1, right? So for this reaction delta Ng is non-zero, so you can say Kp won't be equal to Kc for the last one, right? Clear to everyone? A very simple question again. Let's move on to one more question. This is one more question, people. We can solve this properly. See, I'm giving you the reaction. The reaction is AB3 in equilibrium with AB2 plus half of B2. I believe this sort of a question we have done already in the long-term sessions if you have followed, right? Yes? Okay. Sir, it is a solid. Which one is solid? Did I take solid? Okay, this one is solid, sorry. I forgot. This one is solid. So it's going to be 2 minus 1. 2 minus 1 comes out to be 1. So delta Ng for this reaction is 1. Anyways, it's non-zero. If it is non-zero, that means Kp won't be equal to Kc. Perfect. Let's move on to one more. See, guys, look at the reaction carefully. The reaction is AB3 gas in equilibrium with what? In equilibrium with AB2 gas. And with this, you are writing half of B2 gas, right? This is the reaction that's given to me, right? Now, people, look at the parameters which are given. At time t is equal to 0 initially. If the initial pressure of AB3 is 900 torr, so initially the pressure of AB3 is 900 torr, so this is going to be 0, this is going to be 0, right? Now, people, what I'll be doing? I will be treating the pressures in the same way as we used to treat the moles. I'll be treating the pressure in the same way as we used to treat the moles. So it's going to be 900 minus x, right? 1 mole gives 1 mole, so x mole should give x. 1 mole gives 1 by 2 moles, so x mole should give x by 2, right? So basically, this is basically the pressure of AB3 at equilibrium. This is the partial pressure of AB2 at equilibrium. This is the partial pressure of B2 at equilibrium, right? Now, people, at equilibrium, the total pressure of the system, As per Dalton's law, at equilibrium, there will be some moles of AB3 left in the container. There will be some moles of AB2 in the container. There'll be some moles of B2 in the container as well. So I'll say the total pressure of the system at equilibrium will be the sum of partial pressure of each. Correct? Right, people? So it's going to be 900 minus x plus x divided by 2. So this and this got cancelled. Total pressure of the system at equilibrium is given to me as 1000, right? So it's going to be 1000 is equal to 900 plus x divided by 2. So from here, you'll be getting the value of x as 200 torr, right? You got the value of x. Well, people, if you got the value of x, so 900 minus x, 900 minus 200 comes out to be 700, right? X, that is 200. X divided by 2 comes out to be 100. Well, you got the exact partial pressure of each reactant and product at equilibrium. Once you get the exact partial pressure of each reactant and product at equilibrium, you can write the expression for Kp. Kp expression is going to be partial pressure of AB2 at equilibrium, that's 200, raised to the power its stoichiometric coefficient, that's 1, multiplied by partial pressure of B2 at equilibrium, that's 100, raised to power stoichiometric coefficient, that's 1 by 2, divided by partial pressure of AB3 at equilibrium, which is 700, raised to the power stoichiometric coefficient, that's 1. Now it's going to be your job to do the calculation, get the value of Kp, which is something I was supposed to calculate, right? Yes, people? Done and dusted, right? So finally, you will be getting the answer as something as 2.857, right? Exactly. Moving on to one more question. Okay, this is one more question, guys. Again, a very simple question. This question was asked in this year JEE Mains, okay? It was asked in JEE Mains 2021. See, guys, what kind of a simple question this is. The equilibrium constant at 298 Kelvin for the reaction A plus B gives C plus D is 100. All right. The reaction that's given to me as A plus B in equilibrium with C plus D, right? This is the reaction given to me. I'm given with its equilibrium constant as well. I'm given with the value of Kc over here, which is how much? Which is 100. Correct? If the initial concentration of all the 4 species were 1 molar, so at time t is equal to 0, the initial concentration of every species over here is 1 molar. It's given in the question itself, right? It's given in the question itself. Initially, the concentration of each reactant in the product is 1 molar. Then calculate equilibrium concentration of D. We are supposed to calculate the concentration of D at equilibrium. Now, how will I be doing it? Again, a very simple thing. See, guys, let's assume at equilibrium, out of 1 mole of A, X moles have reacted. So I'll be left with 1 minus X moles of A at equilibrium. Right? Similarly, I'll be left with 1 minus X moles of B at equilibrium, right? Since you got to know 1 mole of A gives 1 mole of C, right? So X moles should give X moles, right? Already you have got 1, it's going to be plus X. Similarly, it's going to be 1 plus X, right? Already the concentration was 1, 1. Now some new moles of C are getting formed and new moles of D are getting formed at the same time because the reaction is proceeding, correct? Right, people? So let me write the Kc expression. Kc expression is going to be concentration of C at equilibrium, which is 1 plus X, concentration of D at equilibrium 1 plus X. So it's going to be 1 plus X ka whole square divided by 1 minus X ka whole square. So let me write it as 1 plus X divided by 1 minus X ka whole square, right? This is equal to Kc. Kc value is equal to 100, right? So from this equation, you'll be getting 1 plus X divided by 1 minus X is equal to 10, right? Let's try to solve it a bit. It's going to be 1 plus X is equal to 10 minus 10X. So from here, you get the value of X as 9 divided by 11, right? Well, you got the value of X, but you were not supposed to calculate the value of X. What we were supposed to calculate? We are supposed to calculate the concentration of D at equilibrium. And as you can see, concentration of D at equilibrium is 1 plus X. Concentration of D at equilibrium is 1 plus X. So it's going to be 1 plus 9 divided by 11, which comes out to be 20 divided by 11, which is going to be around 1.8 something, right? That's something which I was supposed to calculate. I'm sure it's clear to everyone, right? Right, people? Exactly. Yeah? Oh, yeah, Arshad? Exactly, I remember. We did this in yesterday's JEE mock test as well, yeah? Okay. Moving on to one more question then. This is one more question on your screen. A very simple and ordinary question, right? Value of Kp in the reaction. This is your NT equation, right? This is your NT equation basically. You are going to write the Kp expression for this reaction. Well, it's simple. Kp is going to be equal to partial pressure of MgO, which is a solid, nothing to do with this. This is solid, nothing to do with this. So Kp is simply going to be partial pressure of carbon dioxide at equilibrium raised by its stoichiometric coefficient. That's 1. Done and dusted, right? What kind of equation is this? Yeah? Right, people? Right? Okay. Let's move on to one more. Someone is saying, sir, please increase the level of the equations. Bro, this is NEET. This is not J Advanced. You get these sort of questions in your NEET, right? I hope you know it. Perfect. A vessel of 1 liter capacity containing 1 mole of SO3 is heated till a state of equilibrium is attained, right? At equilibrium, 0.6 moles of SO2 had formed. Okay, the value of K will be, right? Can you give it? Can you give it a try? Can you give it a try? Let me know its answer fast. Can you give it a try, people? See, the reaction that's given to me, it's 2 times SO3 gas in equilibrium with what? In equilibrium with 2 times SO2 gas plus what? Plus O2 gas. This is the reaction that's given to me, right? Now, as per the equation, the vessel in which the reaction is taking place, its volume is 1 liter. Its volume is 1 liter containing 1 mole of SO3. Okay, so at time t is equal to 0, I have got some 1 mole of this. So this is going to be 0, this is going to be 0, right? Let's assume at equilibrium, out of 1 mole of SO3, x moles have dissociated. So I'll be left with 1 minus x moles of SO3 at equilibrium, right? Now use the stoichiometry. 2 moles gives 2 moles, 1 mole gives 1 mole, so x moles should give x moles, right? Similarly, 2 moles gives 1 mole, 1 mole gives 1 by 2 moles, so x moles should give x by 2 moles. I got the moles of each reactant and product at equilibrium, right? I got the moles of each reactant and product at equilibrium, right? Now, people, in the question itself, it's mentioned 0.6 moles of SO2 had formed. So at equilibrium, you have got some 0.6 moles of SO2. And the moles of SO2 at equilibrium is x. So basically, I got the value of x. X is basically 0.6 as per the question itself, right? X is 0.6, right? If you got the value of x, it's going to be 1 minus x, that means 0.4, right? X value, that is 0.6. X divided by 2, that means 0.6 divided by 2 comes out to be 0.3. I got the actual moles of each reactant and product at equilibrium, right? Let's convert these moles into concentration. How you'll be doing that? Divide the moles of each reactants and products by the volume of the system in liters. Volume of the system in liters is 1. This is 1. This is 1. Now, this is what I call as concentration of SO3 at equilibrium. This is what I call as concentration of SO2 at equilibrium. This is what I call as concentration of O2 at equilibrium, right? Now, people, you need to get the value of Kc as per the equation. So the value of Kc is going to be concentration of SO2 at equilibrium, that is 0.6, raised to the power its stoichiometric coefficient, that's 2, multiplied by concentration of O2 at equilibrium, that's 0.3, raised power its stoichiometric coefficient. What is its stoichiometric coefficient? It's 1 by 2. It's 1 or 1 by 2? It's 1. Okay, it's 1. Divided by concentration of SO3 at equilibrium, which is 0.4, raised power its stoichiometric coefficient, that's 2. Yeah? Solve it, get the value of Kc. That's something you are supposed to calculate, right? Right, people? Perfect. So what is the final answer which you are getting from here? So finally, after solving, you get the value as 0.68, right? Yes, Siva, you can watch that session as well. Perfect, people. Moving on to one more. For the reaction A plus B in equilibrium with 2C, 2 moles of A, 1 mole of B and 1 mole of C are placed in a 10 liter vessel, are allowed to react and equilibrium is attained finally. If the final concentration of C is 0.2 molar, calculate Kc. Okay, this is one more question. Let's try to solve it. Let's try to solve it, guys. The reaction that's given to me is A plus B in equilibrium with what? In equilibrium with 2 times C. This is the reaction that's given to me, right? Now at time t is equal to 0, initially, at time t is equal to 0, I've got some 2 moles of A, correct? I've got some 1 mole of B, and at the same time, I've got some 1 mole of C as well, placed in a 10 liter container. The container in which the reaction takes place, its volume is 10 liters, right? Its volume is 10 liters, correct? Now, people, at time t is equal to 0, I've got 2 moles of this, 1 mole of this, and 1 mole of this. Now, when the reaction will start, after few minutes, when the reaction will start, there will be equilibrium established in the reaction, right? After some time, you'll find out the reaction will attain equilibrium. And let's assume at equilibrium, out of 2 moles of A, some x moles have reacted. So I'll be left with 2 minus x moles of A, right? Similarly, I'll be left with 1 minus x moles of B at equilibrium, right? Similarly, what is going to be the concentration of C at equilibrium? Already, there was 1 mole of C. Now, apart from this 1 mole, since 1 mole of A gives 2 moles of C, so x moles gives 2x, so 1 plus 2x, these are the moles of C at equilibrium, right? These are the moles of C at equilibrium, right? Now people, I got the moles of each reactant and product at equilibrium. Let me divide these moles by the volume of the system in liters. I'm dividing this by 10, this by 10, this by 10, right? So I got the concentration of each reactant and product at equilibrium. This is the concentration of each reactant and product at equilibrium, right? Now people, what is given in the equation? If the final concentration of C is 0.2 molar, what does that mean? That means concentration of C at equilibrium, it's given to me as 0.2. And we got to know what is the concentration of C at equilibrium. It's 1 plus 2x divided by 10. 1 plus 2x divided by 10 is 0.2. 0.2 means 2 divided by 10. 10 got cancelled. So it comes out to be 2x is equal to 1. So x is equal to 1 by 2. That means 0.5. So you got the value of x, right? You got the value of x. If you got the value of x, put the value of x into these expressions over here. So 2 minus 0.5 means 1.5. 1.5 divided by 10 means 0.15. So this is basically the concentration of A at equilibrium. 1 minus 0.5 means 0.5. 0.5 divided by 10 means 0.05. Right? This is the concentration of B at equilibrium, right? And this term already we know it is 0.2. Well, you got the concentration of each reactant and product at equilibrium. What you were supposed to calculate? You were supposed to calculate the value of Kc. Now write the expression for Kc. It's going to be concentration of C at equilibrium, that's 0.2, raised by stoichiometric coefficient 2, divided by concentration of A at equilibrium, which is 0.15, raised by stoichiometric coefficient, that's 1, multiplied by concentration of B at equilibrium, which is 0.05. 0.05 raised by its stoichiometric coefficient, that's 1. Solve it, get the value of Kc, that's it, right? Let me know in the chat box if it's clear to everyone, people. So people are saying final answer is coming out to be 16 by 3, is that? So 16 by 3 is something which you get the value of Kc for this, yeah? Right? Done and dusted, right? Exactly. Let's move on to one more question. Okay, one more question, guys. This is a lengthy question, right? Let me have some water first. All right, so the question says 1 mole of N2 and 3 moles of H2 are placed in a 1 liter vessel. Find the concentration of NH3 at equilibrium. If equilibrium pressure is 1 atm and the equilibrium constant Kc is at 400 Kelvin is 4 divided by 27, right? Yes. So this is the question which we are going to solve now. See guys how it's to be solved. First of all, you all must be knowing when N2 reacts with H2, it leads to the formation of NH3, right? It leads to the formation of NH3. So let's try to balance the reaction first. This should be 3 times, this should be 2 times. The reaction is balanced, right? Now people, Kc value for this reaction is given to me as 4 by 27. 4 by 27, this is the Kc value, right? Now how do I approach to this sort of equation? Understand. What do I need to calculate? If the equilibrium pressure is this, the equilibrium constant Kc is this, what do I need to calculate exactly? Find the concentration of NH3 at equilibrium. I need to calculate the concentration of NH3 at equilibrium. Now the point is how to do it. See guys, at time t is equal to 0, initially, I'm starting with 1 mole of N2. I'm starting with 3 moles of H2. So there'll be 0 moles of NH3 in the beginning, right? Yes, people. Now at equilibrium, let's assume out of 1 mole of N2, x moles have reacted. So I'll be left with 1 minus x moles of N2 at equilibrium, right? Now use the stoichiometry. 1 mole reacts with 3 moles. So x moles will react with 3x moles. I had some 3 moles. Out of 3 moles, 3x moles are reacting. So I'll be left with 3 minus 3x moles of H2 at equilibrium, right? Now similarly, 1 mole gives 2 moles. So x moles should give 2x moles. I got the moles of each reactant and product at equilibrium, right? Now people, the reaction is taking place in a container whose volume is 1 liter, right? I got the moles of each reactants and products at equilibrium, right? So if I divide this term by 1, if I divide this term by 1, if I divide this term by 1, so these moles will get converted into concentrations. So basically I got the concentration of each reactant and product at equilibrium, right? So let me write the expression for Kc. Expression for Kc is equal to concentration of NH3 at equilibrium, which is 2x. 2x raised by stoichiometric coefficient, that's 4x square, right? Divided by concentration of N2 at equilibrium, which is 1 minus x. Concentration of H2 at equilibrium, which is 3 minus 3x raised by stoichiometric coefficient, that's 3, right? This value is actually equal to Kc, right? This is Kc, and Kc as per the equation is 4 divided by 27. I hope every single thing is clear till here, right? Now people, can I say this 4 and this 4 got cancelled? So I'm getting something as x square divided by, understand properly, this is 1 minus x, okay? So if I take 3 out from here, it's going to come out as 27 because the cube over here, it becomes 1 minus x raised power 3 is equal to 1 divided by 27. Can I see this 27 got cancelled out, right? So what am I getting finally? I'm getting x square divided by 1 minus x raised power 4. So it comes out to be x square divided by 1 minus x raised to the power 4 is equal to 1, right? I'm sure it's clear till here. Now people, it's going to come as x divided by 1 minus x ka square whole raised power 2 is equal to 1. I can write it like this as well. If I take root on both the sides, so square gets cancelled, under root of 1 is 1 only. So finally I get x divided by a square plus b square minus 2ab, correct, is equal to 1. So from here I'll be getting a quadratic equation. Quadratic equation will be x is equal to 1 plus x square minus 2x. Correct? So quadratic equation is going to be x square minus 3x plus 1 is equal to 0. Well people, if you got the quadratic equation, you can find its roots. X is equal to minus b plus minus root of b square minus 4ac divided by 2a. Correct? So from here you get the value of x, right? Once you get the value of x, you need to put the value of x into these expressions over here. You'll be getting the actual concentration of reactants and products at equilibrium, right? Once you get the value of x, put the value of x into these expressions. What I need to calculate? I need to calculate concentration of NH3 at equilibrium. And we know concentration of NH3 at equilibrium is equal to 2 times x. Once you get the value of x, multiply that x with 2, you get the concentration of NH3 at equilibrium. And finally, you get the answer as 0.762 molar, right? Right, people? Exactly, Maran. This is totally cakewalk, right? I don't know physics. Alright, let's move on to one more. This is the reaction that's given to me. See, what am I supposed to calculate and what are the things which are given to us? The reaction says N2 plus H2. The reaction says N2 plus 3 times H2 gives 2 times NH3, right? Okay, this is the reaction that's given to me. Correct? Correct, people? Right? So this is the reaction that's given to me. N2 plus 3 times H2 gives 2 times NH3. Now the partial pressure of N2 and H2 are 0.8 and 0.4 atm at equilibrium. The total pressure of the system at equilibrium is 2.8. Calculate Kp for the reaction. Well people, it's mentioned in the question at equilibrium, the partial pressure of N2 is 0.8 atm. The partial pressure of H2 is 0.4 atm, right? It's mentioned in the question. The partial pressure of N2 is 0.8 atm. Partial pressure of H2 is 0.4 atm, right? And the total pressure of the system at equilibrium is also given to us. It's given to us as 2.8 atm. Can I say, as per the Dalton's law, the total pressure of the system at equilibrium will be the sum of partial pressures of each reactants and products at equilibrium, right? So isn't it going to be 0.8 plus 0.4 plus partial pressure of NH3 at equilibrium, right? Is equal to 2.8. So from here, can I calculate the partial pressure of NH3 at equilibrium? It'll be, this is going to be 1.2, so it's going to be 1.6 atm, right? I got the partial pressure of NH3 at equilibrium. Already I knew the partial pressure of N2 at equilibrium. I knew the partial pressure of H2 at equilibrium. I can clearly say Kp is going to be equal. Partial pressure of NH3 at equilibrium is 1.6 atm raised power stoichiometric coefficient 2 divided by partial pressure of N2 at equilibrium, which is 0.8 raised power stoichiometric coefficient, that's 1, right? Multiplied by 0.4 raised to the power 3. You can solve it. You will be getting the value as 50 and its units are going to be atm raised power delta Ng. Delta Ng for this reaction is minus 2. So this is the value of Kp, right? How many of you got this? How many of you got this, people? No, Nikhil, I teach on this channel as well, apart from EJ Enthuse. Okay? Perfect, people. So let's move on to one more question then. This is going to be your one more question. Okay, this is one more question, right? What do I need to calculate? For the reaction x plus y in equilibrium with 2z, right? 1 mole of x, 1.5 moles of y, 0.5 moles of z were taken here only. Okay, at equilibrium the concentration of z is 1 mole per liter, the equilibrium constant for... People, can you solve this question on your own? Can you solve this question on your own, people? It's a very similar question, right? It's a very similar question. Or you want me to solve it? Let me know fast. You want me to solve it right now? How many of you want me to solve it right now? Okay, let me try to solve it. All right, let me try to solve it. I'll be a little fast. So first of all, the reaction that's given to me is x plus y in equilibrium with 2 times z, right? This is the reaction that's given to me. At time t is equal to 0, how many moles of x am I given with? I'm given with 1 mole of x. How many moles of y am I given with? I'm given with 1.5 moles of y. And how many moles of z I'm given with? I'm given with 0.5 moles of z, right? This is the data that's given to me. And the reaction is taking place in a vessel whose volume is 1 liter, right? What do I need to calculate exactly? I need to calculate what are allowed to react at equilibrium. The concentration of Z is 1 molar. It's mentioned that the concentration of Z at equilibrium is 1 mole per liter, or you can say 1 molar, right? What do I need to calculate? I need to get the value of Kc. I need to get the value of Kc. Now people see, at equilibrium, let's assume out of 1 mole of X, some X moles have reacted, so I'll be left with 1 minus X moles of this reactant at equilibrium. Similarly, 1.5 minus X, these are going to be the moles of Y at equilibrium. Similarly, say 1 mole gives 2 moles. 1 mole gives 2 moles, right? So X moles should give 2X moles. So it's going to be 0.5 plus 2X. These are the moles of Z at equilibrium. Well, I got the moles of each reactant and product at equilibrium. Now, what do you need to do? What do you need to do? You need to divide these moles of reactants and products by the volume of the system in liters. You'll be getting the concentration of each reactant and product at equilibrium, right? Since volume of the system is 1 liters, so I can say whatever are the moles of reactants and products at equilibrium, same is going to be their concentration, right? The equation is almost done. Well, people, the concentration of Z at equilibrium is 1 molar. Now, what is the concentration of Z at equilibrium? It is 0.5 plus 2x. So 0.5 plus 2x is basically equal to 1. So from here, you get the value of x as 1 minus 0.5 is 0.5. So x value you'll be getting as 0.25, right? Since you got the value of x, 1 minus 0.25 means 0.75. 1.5 minus 0.25 means 1.25. And this term, 0.5 plus 2x, 0.5 plus 2x, this value is coming out to be 1 already, right? You got the concentration of each reactant and product. Now you need to write the expression for Kc. Is it going to be concentration of Z at equilibrium? That's 1. Raised power its stoichiometric coefficient, that's 2. Divided by concentration of X at equilibrium, that is 0.5, 0.75. Raised power its stoichiometric coefficient, that's 1. Multiplied by concentration of Y at equilibrium, which is 1.25. Raised power its stoichiometric coefficient, that's 1. You need to solve this, get the value of Kc from here, right? That's something which I was supposed to calculate, yeah? Okay, so finally, after solving this part, you'll be getting the value of this one. Okay, what do I need to calculate basically? It's mentioned in the question that the equilibrium constant is equal to x by 15. Okay, after solving this part, you are going to equate it to x by 15. So from here, you'll be getting the value of x, and x value will come out to be 16, right? Okay, I hope you got it. Perfect, people. Let me know fast in the chat box if it is clear. Let me know fast in the chat box if it is clear. Right? Perfect. So let's move on to one more then. Okay, which of the following information can be obtained on the basis of Le-Chatelier principle? This question you are going to do on your own. I'm not going to do it. Let me know fast. Let me know fast. What kind of information Le-Chatelier principle gives us? It gives us the idea of the shift of equilibrium, whether the equilibrium is shifting towards forward or backward, right? Yes? Right, people? So option D is the one which is the answer of the question. Okay, for the reversible reaction, the equilibrium shifts in the forward direction. Okay, you need to see how come this reaction will shift in the forward direction. If you will increase the concentration of NH3, equilibrium will try to decrease it. How? It will make sure the reaction moves in the backward direction. So if you will increase the concentration of NH3, the reaction moves in backward direction, right? By decreasing the pressure. See guys, first of all, how many total moles do we have on reactant side? 3 plus 1, 4. How many total moles do we have on product side? 2, right? When the forward reaction occurs, are the moles increasing or decreasing? Moles are decreasing. That means in the forward direction, pressure is decreasing. And in the backward direction, since moles are increasing, so pressure will be increasing at the same time in the backward direction. Now, if we decrease the pressure, equilibrium will try to increase it. And how equilibrium will increase it? It will make the reaction to move in the backward direction. Again, reaction moves in the backward direction. By decreasing the concentration of N2 and H2. If I decrease the concentration of N2 and H2, equilibrium will try to increase it. How? It will again make sure the reaction moves in the backward direction. So there is only one option left. That's going to be option D. So option D is going to be the answer of the equation, right? Right, people? Perfect. Let me move on to one more question then fastly, right? Okay, the reaction quotient for the reaction. All right. The reaction will proceed from right to left. That means, when will the reaction proceed in backward direction? When will the reaction proceed in backward direction? When will the reaction proceed in backward direction? Remember guys, I'm giving you the conditions. If QC is greater than equilibrium constant, if reaction quotient is greater than equilibrium constant, reaction moves in the backward direction. Remember, if QC is less than equilibrium constant, okay, reaction moves in the forward direction. And remember, if QC is equal to K equilibrium, you can clearly say the reaction is already at equilibrium. Right? These three conditions, we have discussed this in detail in the regular sessions, right? So just remember the conclusions now. Yeah? These are the conclusions. What do I need to check? The reaction will proceed from right to left. That means backward direction. When the reaction proceeds in backward direction, when QC is greater than KEQ, that means option D is the one, which is the answer of the equation. I'm sure it's clear to everyone, right? Yes, Sherlock, at that time you need to calculate instantaneous. Okay, if it's not mentioned in the equation, whether you are supposed to calculate average rate or instantaneous rate, you are supposed to calculate instantaneous rate. Okay? Yes, Ria, I have been to Kerala once. Okay, moving on to one more, guys. For the reaction is given to us. Delta H is positive. That means the reaction is endothermic. Yeah? In equilibrium condition, pressure of O2 is dependent on. In equilibrium, first of all, if you write the expression of Kp for the reaction, expression of Kp is going to be simply partial pressure of O2, right? So people understand. Delta H is positive. In equilibrium condition, the pressure of O2 is dependent on mass of BaO2. No way, because it's in solid. It has got nothing to do with it. Okay. Mass of BaO, nothing, right? Mass of this and this, no way. So only thing, that is temperature, right? See, if you are writing the Kp for this reaction, it comes out to be partial pressure of O2. That means partial pressure of O2 depends on Kp, and Kp, equilibrium constant, it depends on temperature, right? You all must be knowing equilibrium constant depends on temperature. So on changing the temperature of the reaction, Kp changes, and if Kp changes, that means partial pressure of O2 automatically changes, right? So option C is the one which is correct. Right, people? Okay, what about this one? The reaction is taking place somewhere in a closed container. What would be the effect of addition of calcium carbonate? If you will add calcium carbonate in this reaction, will there be any effect on equilibrium? There will be no effect on equilibrium because this is in solid form. It is in solid form. If you are adding or subtracting solid from the reaction at equilibrium, nothing happens to the equilibrium, right? So equilibrium remains unaffected, okay? So option D is the one which is the answer of the equation. Perfect? Okay, let's move on to the ionic equilibrium part. People, let me know, is everything clear till here? Fast. Fast, let me know. Just a second, guys. The ones who have not liked the video, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Okay? So I believe everything is super duper clear till here. Well, I'm already getting the answers. Is that? That's great. So let's try to be super fast, guys. Let's try to solve the equations with the super fast speed, yeah? Okay, the pH of 0.01 molar NaOH. First of all, NaOH, as you all must be knowing, it's a strong electrolyte. It would have got completely dissociated as Na positive plus OH negative, right? Yes, Na positive aqueous plus OH negative aqueous, correct? Now people, at time t is equal to 0, the concentration of NaOH is 0.01. This is 0, this is 0. Now this NaOH is a strong electrolyte. It would have got completely dissociated into its ions. So I'll be left with 0. 0 is going to be the concentration of NaOH after some time. This is going to be 0.01. This is going to be 0.01. So you got the concentration, the resulting concentration of OH negative in the container, that's 10 raised power minus 2, right? That's 10 raised power minus 2. If you got OH negative concentration, can we calculate POH? Absolutely, which is minus log of OH negative concentration, right? OH negative concentration we got, the value comes out to be 2. If you got the POH value, you can clearly say pH is equal to 14 minus POH, the value comes out to be 12, right? The answer of this question is going to be 12, which is option D, right? Done? Done, people? A simple question, a basic question this is. A basic question this is, right? Perfecto. All right, let's move on to one more question, guys. Calculate the H positive ion concentration of a 0.05 molar CH3COH solution. Ka for this acid is given. See, again a simple question, just remember the procedure, that's it. We have got CH3COH, which is a weak acid, and weak acid is the example of the weak electrolyte, and remember, weak electrolyte always remains in equilibrium with its ions, and its ions are going to be CH3CO negative aqueous plus H positive aqueous, right? Yes, people? At time t is equal to 0, let's say concentration of this is C, this is going to be 0, this is going to be 0. Let's assume degree of dissociation is alpha, so at equilibrium, the concentration of CH3COH is going to be C minus C alpha. This is going to be C alpha. This is going to be C alpha. You all must be familiar with this, right? You all must be familiar with this, right? Yes? Now, people, I can say Ka is equal to, what is Ka? Ka is what we call as ionization constant of weak acid, right? Its expression is written in the similar way as we write the expression for equilibrium constant, right? So it's going to be concentration of CH3CO negative at equilibrium, which is C alpha, multiplied by concentration of H positive at equilibrium, which is C alpha, divided by concentration of CH3COH at equilibrium, which is C minus C alpha. So the value comes out to be C alpha squared divided by 1 minus alpha. Now, people, understand, remember from now onwards, if the value of alpha will be far less than if the value of alpha will be less than 0.05, at that time you can neglect alpha wherever you want to. Okay, so I'm assuming in this question, if alpha value is less than 0.05, so instead of 1 minus alpha, I can only write 1 at that time. So I can say Ka is equal to C alpha square, Ka is equal to C alpha square, and alpha is going to be under root of Ka divided by C. Well, people, Ka value as per the question is given to me 1.25 into 10 raised power minus 6, okay, divided by concentration of CH3COH. It's given to me as 0.05, correct? Can you solve it and let me know? Can you solve it and let me know fast? This is going to be 1 times, this is going to be 25 times, so under root of 25 is 5, so 5 into 10 raised power minus 3 is alpha. Alpha is 5 into 10 raised power minus 3, that means alpha is 0.005. Alpha is 0.005. So is the value of alpha actually coming out to be less than 0.05? Yes. That means whatever neglection we have done right here, that's absolutely correct. That's absolutely correct, right? Yes, alpha is neglected. Whatever neglection we have done, that's absolutely correct. Because we got the actual value of alpha actually to be less than 0.05, right? Now, people, alpha is done. What do I need to calculate? I need to get the value of H positive concentration, right? So I can say concentration of H positive at equilibrium is going to be equal to what? It's going to be C multiplied by alpha. C value is the concentration of CH3COH. It's given to me as 0.05. So 0.05 multiplied by alpha is 0.005. Solid, that's going to be the concentration of H positive. Finally in the container, right? As simple as that. Right, people? So the answer is going to be 25 into 10 raised power minus 5 molar. Yeah? Right. Let me know fast in the chat box if it is clear. Perfectly done, guys. Perfectly done. Let's move on to one more question then. This is one more question on your screen. Calculate ionization constant of a weak base NH4OH. If the concentration of OH negative ion in its 0.1 molar aqueous solution is 0.05 molar. How do we approach to this sort of equation? Understand, it's again a very similar and common type of equation. I'm given the weak base. What is my weak base over here? It's NH4OH. If it is a weak base, it is a weak electrolyte, and weak electrolyte remains in equilibrium with its ions, and its ions are going to be NH4 positive aqueous plus OH negative aqueous, right? Calculate the ionization constant of a weak base if the concentration of OH negative ions, okay, concentration of OH negative ions, it's given to me as per the equation, if the concentration of OH negative ions in its 0.1 molar aqueous solution is 0.05. So concentration of OH negative is given to me as 0.05, and at the same time at time t is equal to 0, the concentration of NH4OH, which I represent by C, that's also given to me as 0.1, right? This is going to be 0, this is going to be 0. Let's say degree of ionization is alpha, so this is simply going to be C minus C alpha, this is going to be C alpha, this is going to be C alpha, right? Now people, concentration of OH negative finally is given to me as 0.05. And what is the concentration of OH negative finally? That is C alpha. Basically, C alpha value is 0.05. So from here, alpha will be 0.05 divided by C. What is C? C value is 0.1. C value is 0.1. So alpha value is 0.5. Alpha value is 0.5. Well people, is the value of alpha coming out to be less than 0.05? No, the value of alpha is not coming out to be less than 0.05. So I cannot neglect alpha in comparison to 1, right? So you can clearly say Kb is equal to, what is Kb? That's going to be C alpha square divided by 1 minus alpha. We cannot neglect alpha. C value is given to me as 0.1. Alpha square is going to be 0.5 square divided by 1 minus 0.5. Now it's going to be your job to do the calculation, get the value of Kb. That's something which I was supposed to calculate fast. Fast people. Raja, there is no quadratic which gets formed in this case. Why you are getting quadratic in this case? Alpha value you got, right? Put the value of alpha in this equation. The equation is done and dusted, right? How come Mahia you are getting quadratic in this? You can get quadratic if alpha value was not given, right? Perfect. Perfecto people. All right, so let's move on to one more question then. Okay, conjugate base for Bronsted acids H2O and HF. Kill this one, let me know its answer fast in the chat box. Let me know guys. We are given with two Bronsted acids H2O and HF. What are their conjugate bases? Conjugate bases. H2O after losing H positive gets converted into OH negative. So OH negative is the conjugate base for H2O, right? HF after losing H positive gets converted into F negative. F negative is the conjugate base, right? So OH negative and F negative are the conjugate bases of these Bronsted acids, right? So option C is the one which is correct among all. No need to think a lot about this question as well. Okay, one more question people, one more question. See how this sort of equation is solved. What is the concentration of H positive in a solution that is 0.01 molar in HCN and 0.02 molar in NaCN? All right. Ka value is also given, right? So first of all, I'm given with a weak acid HCN. It's going to remain in equilibrium with its ions. Its ions are going to be H positive aqueous plus Cn negative aqueous, right? Okay. First thing, I'll be writing the Ka expression for this HCN. It's going to be concentration of H positive at equilibrium multiplied by concentration of Cn negative at equilibrium divided by concentration of HCN at equilibrium, right? Now at the same time, we have got NaCN as well. Now people, NaCN is a salt. It would have got completely dissociated into its ions, Na positive plus Cn negative, right? Now people, at time t is equal to 0, what is the concentration of NaCN? That's given to me 0.02. So this is 0.02, this will be 0, this will be 0. Now finally this will be 0, this will be 0.02, this will be 0.02. The question is almost done and dusted. See guys, Ka value I'm given 6.2 into 10 raised power what? 6.2 into 10 raised power minus 10 is equal to H positive concentration we need to calculate. Cn negative concentration. What is the Cn negative concentration? It is 0.02. It is 0.02. What is the HCN concentration? HCN concentration. HCN concentration is 0.01, right? 0.01. So from this equation, you just have one variable, that's concentration of H positive. You can calculate it. The equation is done, right? Right, people? The equation is done and dusted, right? One variable only. So H positive concentration will find out to be 3.1 into 10 raised to the power minus 10, right? Perfect. Let's move on to the next, guys. Let's move on to the next. Okay, calculate the pOH of the solution at 25 degrees centigrade that contains 10 raised power minus 10 molar of hydronium ions, H3O positive ions. Either you write H3O positive or you write H positive. It's similar, right? Either you write H positive or H3 or positive. It's similar for you. Okay. Now, people, as per the ionic product of water, concentration of H positive multiplied by concentration of OH negative is always equal to 10 raised power minus 14 at 25 degrees centigrade, right? Okay. Perfect. Now, people, you're given with the concentration of what? You're given with the concentration of H positive, which is 10 raised power minus 10. So you can say OH negative concentration is going to be 10 raised power minus 14 divided by 10 raised power minus 10. The value comes out to be 10 raised power minus 4. So you got the OH negative concentration. If you got the OH negative concentration, you can calculate POH, which is minus log of OH negative concentration. The value will come out to be 4. If POH you got, you can calculate pH as well. pH is going to be 14 minus POH. The value comes out to be 10. What was I supposed to calculate? pH ki POH. Okay, I was supposed to calculate POH only. This is something which I was not supposed to calculate. So answer is going to be 4 only, yeah? Right. Perfect. Exactly. Let's move on to one more then. Let's move on to one more. What kind of equation this is? Accumulation of lactic acid, a monobasic acid in tissues leads to pain, my god, and a feeling of this. In a 0.1 molar aqueous solution, lactic acid is 3.7% dissociated. The value of dissociation constant Ka for this acid will be. Okay, it's a very difficult equation, guys, right? See, you are given with the percentage dissociation of the lactic acid, which is 3.7. So can we calculate alpha for the lactic acid, which is percentage dissociation multiplied by 100? The value comes out to be how much? The value comes out to be 0.037. This is the value of alpha. Is it less than 0.05? Yes, it's less than 0.5. I mean, it is less than 0.05. So wherever I need to neglect alpha, you can do that. Just use the value Ka is equal to C alpha square divided by 1 minus alpha, right? Alpha you can neglect, so remove this 1 minus alpha. So from here, you can calculate Ka. You can calculate Ka is going to be C alpha square. C is the concentration that must be given to us, 0.0, 0.1. Alpha square, alpha is 0.037 ka square. Solid, that's going to be Ka, which is something I was supposed to calculate, right? Right, people? The equation is done. The equation is done, right? Ka is equal to C alpha square divided by 1 minus alpha, right? Alpha is already less than 0.05. Neglect it. Okay? So C is given, alpha is given. Kill it. So what is going to be finally the answer? Finally, the answer is going to be 1.4 into 10 raised power minus 4. When you solve this part, you get the answer as 1.4 into 10 raised power minus 4. Yeah? Right, people? So don't be afraid by just looking at the equation. Big question, small answer, yeah? Okay, so one more question we have, guys. A weak acid HA has dissociation constant Ka as this much. If 0.1 mole of this acid is dissolved in 1 liter of water, the percentage of acid dissociated at equilibrium is closest to. Okay, so let's give it a try. Well, I think the answer must be A. The answer must be A or C. Let's check it. So I have got HA first of all. This is going to be H positive aqueous plus A negative aqueous, right? See what all parameters we are given with. Time t is equal to 0. Time t is equal to 0, right? A weak acid HA has Ka of this much. Okay, Ka value is given to me. Ka value is given to me as 10 raised power minus 5, right? If 0.1 mole of this acid is dissolved in 1 liter, right? Moles of acid is given, volume of solution is given. So that means concentration of acid is given to us. And concentration of acid, concentration of HA will be 0.1 only, correct? Will be 0.1 only. 0.1 divided by 1 comes out to be 0.1. So C value is 0.1. This is going to be 0, this is going to be 0. This is C minus C alpha, this is C alpha, this is C alpha, right? Write the expression for Ka. It's going to be C alpha square divided by 1 minus alpha, right? Ka expression is going to be C alpha square divided by 1 minus alpha. Now, people, what I'll be doing, I'll be assuming if alpha is far less than 1, if alpha is less than 0.05, at that time I can neglect alpha. So instead of 1 minus alpha, I can only write 1, right? So I'll be getting Ka is equal to C alpha square, or I can say alpha is equal to under root of Ka divided by C. Ka is given to me, C is given to me, solve it, get the value of alpha. So Ka is given to me as how much? 10 raised power minus 5, right? C is given to me. C is the concentration of this acid, 0.1, 10 raised power minus 1. The value comes out to be 10 raised power minus 2. 10 raised power minus 2 means 0.01. Is 0.01 less than 0.05? Absolutely. So whatever neglection I have done, that's absolutely correct, right? That's absolutely correct. So you got the alpha value, guys. But were you supposed to calculate alpha? Were you supposed to calculate degree of dissociation? No. You were supposed to calculate percent ionization. And you know, percent ionization is equal to percent dissociation, or sorry, percent ionization is equal to degree of ionization multiplied by 100. So it's going to be 0.01 multiplied by 100. The value comes out to be 1%, right? That means 1% of the acid has got dissociated, right? Option A is the one which is correct. Right, people? Done and dusted. Let's move on to one more then. This is one more question. You can kill this one. We have solved this question many a times. We have solved this question many a times, and I want you guys to kill it right now. Right now, people, see the pH of a 0.1 molar solution of salt. See, guys, first of all, NaCl, it's a salt of strong acid and strong base. Strong acid is HCl, strong base is NaOH. HCl plus NaOH gives NaCl, so it's a salt of strong acid, strong base, its pH is 7. This is HCl, its pH is going to be far less than 7. Its pH is going to be less than 7, right? NH4Cl, basically this is NH4 positive, Cl negative. NH4 positive we have got from NH4OH, and Cl negative we have got from HCl, correct? So basically it is the salt of weak base and strong acid. It's the salt of weak base and strong acid. Its pH is again going to be less than 7 only, right? Okay. NaCN, Na positive, Cl negative. Na positive I have got from NaOH, and Cl negative I have got from HCl. This is the salt of strong base, weak acid. So its pH is going to be greater than 7. Greater than 7. Now arrange it on whatever order you have to form. Increasing order, right? Increasing order of pH. So minimum pH is for HCl. Minimum pH is for HCl, right? Then comes your what? Then comes your less than 7. Wait, less than 7 is this one, correct? NH4Cl. Then comes your NH4Cl. Then comes your NaCl. And after NaCl, what comes after NaCl? NaCN comes. This is the increasing order of the pH, correct? Is there any option matching, people? NaCN, NaCl, NH4Cl, HCl. Okay, option B is matching, so option B is the one which is correct among all, right? Right, people? Akashinath Rothre, I'm not getting what you're saying. You're saying in Menti we can consume lesser time. Bro, are you fine? How come in Menti we are going to save the time? Okay, one more question, guys. The pH of ammonium phosphate solution, if Pka of phosphoric acid and Pkb of ammonium hydroxide are 5.23 and 4.75 respectively. Okay, pH. Can you let me know fast? Kishore is saying for NH4Cl, how pH is less than 7. Basically, NH4Cl is a salt. It is a salt which got formed when NH4OH reacted with HCl. NH4OH is a weak base. HCl is a strong acid. Strong acid, weak base. pH is absolutely going to be less than 7 only, right? Yeah? Right, people? So can you let me know its answer fast? Can you let me know its answer fast? So some people are coming out 7.2, 0.48, 7.24, 7.2. Riya, that is Pka minus Pkb in the formula. See guys, first of all, we are doing the hydrolysis of the salt of weak acid and weak base. Salt of weak acid and weak base. When we do the hydrolysis of salt of weak acid and weak base, how do we calculate pH? There's a formula for it. 7 plus half of P of Ka minus P of Kb. Correct? It's going to be 7 plus half of P of Ka value is given to us, I guess, how much? 5.23. P of Kb is also given to me as how much? It's 4.75. Correct? Solid, that's going to be pH. Correct? Finally, you get the answer as 7.24. Right, people? A very simple question. Salt hydrolysis. You are given with the salt of ammonium phosphate. Ammonium phosphate is the salt of weak acid and weak base. And when we do the hydrolysis of the salt of weak acid and weak base, its pH is going to be 7 plus half of Pka minus Pkb, right? Aleem, right now I'm busy with NEET 2021 and JEE 2021 people. Once JEE 2021 gets completed, once NEET 2021 gets completed, I'll be only taking sessions for NEET 2022 and 2023 students, right? Okay. So give me some time till the 12th of September. After that, it's going to be your turn to kill chemistry, right? Perfect. So let's move on to one more question, guys. This is one more question. Calculate the degree of hydrolysis and pH of the solution obtained on dissolving 0.1 mole of this. Okay, first of all, CH3CONA. CH3CONA. First of all, we need to identify which kind of salt this is. This is CH3CO negative, Na positive. CH3CO negative we have got from CH3COH. Na positive we have got from NaOH, right? So this is the salt of weak acid and strong base. It is the salt of weak acid and strong base. When we do its hydrolysis, how do we get KH? KH, which is called as hydrolysis constant. Hydrolysis constant for the hydrolysis of this kind of a salt is going to be Kw divided by Ka. If you need to calculate degree of hydrolysis, it's going to be, the formula is going to be under root of Kw divided by Ka multiplied by concentration of salt, right? If you want to calculate the pH, first of all, it's a salt of weak acid and strong base. So pH is going to be greater than 7. 7 plus half of, it's going to be P of Ka. People, is it going to be plus log C ki minus log C? I don't remember exactly. Is it plus log C ki minus log C? Is it plus log C ki minus log C? Well, I think it should be plus log C only, yeah? Right, it's plus log C. Now people, what is C basically? C is the concentration of salt. C is the concentration of salt. Concentration of salt will be equal to number of moles of salt, which is 0.1 divided by volume of solution in liters. How much is that? That is 100, right? Okay, so the value will be 10 raised power minus 3. This is the concentration of salt. Everything you have, every single thing you have. See, KH is equal to Kw is going to be 10 raised power minus 14. You all must be knowing. Ka value must be given in the equation. 2 into 10 raised power minus 5. You can solve it, get the value of KH from here, right? Similarly, it's going to be under root of Kw is 10 raised power minus 14 at 25 degrees centigrade. Ka value is 2 into 10 raised power minus 5. C value you got to know is 10 raised power minus 3. Done and dusted, right? So 7 plus half of P of Ka. P stands for minus log. So you can take minus log of this value. That will give you Pka plus log of C. C value is already given, correct? You can solve it. I mean, all the 3 questions won't be asked in your exam. Out of these 3, only 1 will be asked. Out of these 3, only 1 will be asked, okay? Out of these 3, only 1 will be asked. And these are the formulas which I mentioned over here on the screen. You'll be getting this formula list in the PDF in your Telegram group, okay? So one more question we have. I'm starting with, this is primary amine, right? Okay, primary amine. Is it a weak acid? I mean, is it a weak base or strong base? It's a weak base. Primary amine is a weak base, right? Okay. Now calculate the pH of 0.01 molar RNH2 solution. Kb value is given to me. All right. So people, at time t is equal to 0, initially, at time t is equal to 0, what is the concentration of this weak base? C is equal to 0.01. This will be 0, this will be 0. Since it's in pure liquid form, its ectomass is taken to be unity. I've got nothing to do with this, right? Now at equilibrium, it's going to be C minus C alpha. Same procedure. This is C alpha. This is C alpha. I can write Kb is equal to C alpha square divided by 1 minus alpha, right? C alpha square divided by 1 minus alpha. Now people, have a look properly. Kb value is given to me. 2 into 10 raised power minus 6. What do I need to calculate? I need to calculate pH, right? In order to calculate pH, I need to know the value of alpha, right? So first of all, I'll be assuming, let's assume alpha value is less than 0.05. If alpha is less than 0.05, then instead of 1 minus alpha, I need to write only 1, right? So I'll be writing Kb is equal to C alpha square, or you can say alpha is equal to under root of Kb divided by C, right? Kb value is given to me as how much? It's given to me as 2 into 10 raised power minus 6 divided by C. C is the concentration of this weak base, which is 10 raised power minus 2, right? So it's going to be root of 2. Root of 2 is 1.41 multiplied by. It's going to be root of 10 raised power minus 4. That's 10 raised power minus 2. So the value will be 0.0.1? 0.0141. This is the value of alpha. This is the value of alpha. Is the alpha value actually coming out to be less than 0.05? Absolutely. So whatever is the alpha value, that's absolutely right. So whatever neglection we have done, that's absolutely right. Now people, I'll be calculating the concentration of OH negative. I'll be calculating the concentration of OH negative. Concentration of OH negative is basically C times alpha. C value already we know. C value already we know, that's 10 raised power minus 2. Alpha value we got to know as well. which is 1.41 into 10 raised power minus 2, 1.41 into 10 raised power minus 2, right? So the value will be finally 1.41 into 10 raised power minus 4. Well, you got the OH negative concentration. You can calculate POH from here, which is going to be minus log of OH negative concentration. You can calculate POH. Once you get the POH, you can calculate pH. That's going to be 14 minus POH. Done and dusted, right? Right, people? Let me know fast in the chat box if it is clear. Fast, fast, fast. Well, some world. I'm done with GOC, I'm done with amines. Next is going to be hydrocarbons. Yes, next is going to be hydrocarbons. Okay. So I'm sure this is also clear. So finally you are getting the POH as 3.85 and finally you get pH as 10.15, right? I'm sure this question is again done and dusted, right? Okay. Perfect, people. So one more question, yeah? How many liters of water must be added to 1 liter of an aqueous solution of HCl with a pH of 1 to create an aqueous solution with pH of 2? Correct? How do we solve this sort of equation? How do we solve this sort of equation? Understand. See, guys. So how many liters of water must be added to 1 liter of an aqueous solution of HCl, right? I have got an aqueous solution of HCl whose pH is how much? Whose pH is 1. Is that? Whose pH is 1. And volume, it's given to me as 1 liter, right? Its volume is given to me as 1 liter. Now this is the aqueous solution of HCl basically, whose pH and volume is given to me, correct? Now I'm diluting it. I'm diluting this solution, right? I'm diluting this solution. I'm diluting this solution unless pH of this solution comes out to be 2. Let's assume final volume of the solution, which I'm representing as V2. That's something which I need to calculate first, okay? So we will understand. Let's assume this is V1 initial volume of the solution, V2 final volume of the solution after dilution, right? Now first of all, if pH is equal to 1, can we calculate the H positive concentration? H positive concentration is simply going to be 10 raised power minus 1 molar, right? Okay, this is something which I call as M1. Concentration molarity is same, right? Similarly, pH over here is 2. pH over here is 2. That clearly means H positive concentration after dilution is going to be 10 raised power minus 2, which I represent by M2, right? Use the dilution formula. The question is done. Use the dilution formula. M1 V1 is equal to M2 V2. Well, people, M1 value is given to us as 10 raised power minus 1. V1 value is given to us as 1. M2 value I got to know as how much? 10 raised to the power minus 2. So from here I'll be getting the V2 value, right? So what is V2 value coming out to be from here? V2 value will come out to be 10 liters. What is V2? V2 is the final volume of the solution. Am I supposed to calculate final value of the solution? I'm not supposed to calculate final volume of the solution. I need to calculate the volume of water added. See, initially you had 1 liter. Finally, after the addition of water, you have got the volume of the solution as 10 liters, right? Initially, volume of the solution was 1 liter. Finally, it is 10 liters. That means how much amount of water you have added? You have added some 9 liters of water, right? You have added some 9 liters of water. So after adding some 9 liters of water, the pH changed from 1 to 2, right? Done? Done, people, with this one as well? I'm sure. Let's move on to one more question, guys, then. Okay, this is one more simple question. Again, the question is based on the pH, right? I'm starting with calcium hydroxide, which is strong electrolyte, okay? So first thing which you all must be familiar with, calcium hydroxide, it would have got dissociated as Ca di positive aqueous plus 2 times OH negative aqueous, right? 2 times OH negative aqueous, correct? Now first thing, people, see, the number of moles of this electrolyte is given. Volume of the solution is given. Can I calculate the concentration? I'll be calculating the concentration of CaOH whole twice first, which is going to be equal to number of moles of calcium hydroxide, which is 5 into 10 raised power minus 4. 5 into 10 raised power minus 4 divided by volume of solution in liters. This is 100 ml. 100 ml means 10 raised power minus 1 liters, right? So it's going to be 5 into 10 raised power minus 3, right? This is the concentration of calcium hydroxide. Is that? This is 5 into 10 raised power minus 4. 0.0005. 5 into 10 raised power minus 4 divided by volume of solution in liters. In liters, it's going to be 10 raised power minus 1, correct? So finally, it will be that 10 raised power minus 1 will go up. So it's going to be 5 into 10 raised power minus 3, correct only. So at time t is equal to 0, I got the concentration of calcium hydroxide, which is 5 into 10 raised power minus 3 molar, right? This is 0, correct? Okay, so finally this will be 0. This is going to be 5 into 10 raised power minus 3. Since the stoichiometric coefficient is 2, it's going to be 2 into 5 into 10 raised power minus 3. Correct? So it's going to be 10 multiplied by 10 raised power minus 3. The value comes out to be 10 raised power minus 2. Right? The value comes out to be 10 raised power minus 2. So you got to know the concentration, the resulting OH negative concentration, which is 10 raised power minus 2. If you got to know the OH negative concentration, you can calculate POH from here. So POH is going to be equal to minus log of 10 raised power minus 2. The values come out to be 2, right? Once you get POH, you can calculate pH as well, which is 14 minus POH, right? So it's going to be 14 minus 2. 14 minus 2 comes out to be 12. So 12 is the pH of the solution which I was supposed to calculate, right? Right, people? Clear to everyone? Clear to everyone? Let me know fast. Is it clear to everyone? Yes, Harshal, tomorrow we'll be having the Menti quiz for class 11 students from the chapter Atomic Structure. Well, guys, you can also join in. NEET 2020 students can also join in, right? Because this week I have not taken any session for class 11 students for NEET 2023. So let's have a Menti session for them. So you 2021 students can also join in for the Menti session, right? Okay, and the questions are going to be very, very simple. Sanifa, I have no idea like how many questions are left. I have no idea. Let me check it first how many questions are left. Just a second. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions are left. That's it. 10 questions. So which question we were solving? This is done. This is done. Just a second, people. Okay, this question we were solving, right? Okay, so let's move on. Let's move on, people. Let's move on. This question is done and dusted, right? Okay, one more question. What is the pH of 10 raised power minus 4 molar OH negative solution at 330 Kelvin if Kw at this is this? Okay. So first of all, Kw value is given to us, right? Kw value is given to us as 10 raised power minus 13.6. Kw, as you all must be knowing, that's concentration of H positive multiplied by concentration of OH negative. This value is basically given to us as 10 raised power minus 36, right? And at the same time, OH negative concentration is also given. So I'll say H positive concentration is going to be 10 raised power minus 13.6 divided by OH negative concentration, which is 10 raised power minus 4. The value comes out to be 10 raised power minus 9.6, right? Right, people? Yeah? Right? It's going to be 10 raised power minus 9.6. If you got the H positive concentration, you can calculate pH. It's going to be minus log of H positive concentration. And it's going to be, answer is going to be 9.6, right? So option A is the one. Right? Okay, let's move on to one more question then. Let's move on to one more question. See, pKa of a weak acid is this much, pKb of a weak base is this much. What will be the pH of the salt formed? It's again a simple question. We have got a salt of weak acid and weak base, and how do we calculate its pH? Its pH is calculated by the formula which I gave you a few minutes back. 7 plus half of, it's going to be P of Ka minus P of Kb, right? So it's going to be 7 plus half of P of Ka value is given to me as per the question. How much? It's P of Ka is given to me 5.76. It's going to be 5.76 minus 5.25, right? Solve it, get the value of pH. It's going to be greater than 7 only. I think 7.2 is the answer, right? 7.2 is the answer. Right, people? Simple equation again. Moving on to one more question. The ionization constant of ammonium hydroxide is this much. Okay, ammonium hydroxide, NH4OH. Hydrolysis constant of ammonium chloride. Ammonium chloride, that means NH4Cl. NH4Cl, it has got two components, NH4 positive, Cl negative. NH4 positive would have come from NH4OH, Cl negative would have come from HCl. So basically, we got to know it is a salt of strong acid and weak base. It is a salt of strong acid and weak base. What do I need to calculate? I need to calculate hydrolysis constant of this one. I need to calculate KH value. KH is simply going to be equal to KW divided by, this is weak base, so it should be KB. KW is 10 raised power minus 14. KB value must be given to us. KB, ionization constant of the weak base, it's given to me 1.77 into 10 raised power what? Into 10 raised power minus 5. Just solve it. That's going to give you the hydrolysis constant KH of the salt. Right, people? Right, so what is the answer of the equation finally? Answer of the equation is coming out to be as D, right? This divided by this is simply coming out to be D. Correct? Right, people? Kishore, in your NEET examination, your calculation part is going to be damn easy. Trust me on that. It's going to be very, very, very easy. Right? Well, I believe this year's NEET paper is going to be the easiest NEET paper among all the NEET examinations which have happened till now. Right? Well, I think majority of the questions will be formula based and direct the memory based questions. Majority of the questions in your chemistry as well as your biology, right? Okay, that's something which I believe, okay? And you can believe me too. Okay, find out the solubility of NaOH whole twice in 0.1 molar NaOH. Given that ionic product is this much. Can you solve this question on your own? Can you solve this question on your own, people? It's a very simple question, right? We have solved these sort of questions in detail. Okay, Fatima is saying, how do we get Kw? Remember, Kw value always you are going to take 10 raised power minus 14 when the temperature is kept at 25 degrees centigrade. If the temperature is not mentioned in the question, then you are going to take the temperature on your own as 25 degrees centigrade and take the Kw value as 10 raised power minus 14. Choice is all yours, right? People, can you solve this question on your own? Yeah? It's a simple question, right? It's a simple question. See, look at its solution first. It's a simple question, guys, right? I hope you remember how to solve these questions. I've solved these questions in detail in the normal sessions. Do you remember how do we solve these? Now people are coming up with option D. Yes, exactly. It's option D. You want me to solve it, guys, or I'll move ahead? You want me to solve it or? Okay, I'll solve it. Have a look. See, guys, understand. Find out the solubility of NiOH whole twice. So first of all, we have got NiOH whole twice, right? It's going to get converted into Ni di positive aqueous plus 2 times OH negative aqueous, right? First thing, let's assume its solubility is S. This is going to be S. This is going to be 2S, correct? Since first of all, this reaction is taking place in a container. In the same container, what am I adding? In the same container, I'm adding NaOH. In the same container, I'm adding NaOH. NaOH is a strong electrolyte. It would have got completely converted into Na positive plus OH negative, right? Its concentration initially was how much? 0.1, right? This would have been 0, this would have been 0. Now finally this will be 0, this will be 0.1, this will be 0.1. Now in the same container, I have got two electrolytes. In the same container, I have got two electrolytes. This is the weak electrolyte, this is the strong electrolyte. And both are having one ion in common. What is that one ion? That is OH negative, right? So what is going to be the resulting OH negative concentration? It's going to be 2S plus 0.1. This is the net OH negative concentration, correct? Now people, whenever in the same container, I'll be having weak electrolyte, strong electrolyte, both containing a common ion. At that time, common ion effect is going to operate, due to which solubility of weak electrolyte will decrease. And I'm assuming solubility of weak electrolyte has decreased and it has come out to be less than 0.05. So I can neglect solubility wherever I want. So 2S plus 0.1, instead of it, I'll be only writing 0.1, right? Okay. Now if I write the ionic product of it, ionic product is going to be concentration of Ni di positive raised by its stoichiometric coefficient multiplied by concentration of OH negative raised by its stoichiometric coefficient, right? Ionic product is given to me as 2 into 10 raised by minus 15. So it's 2 into 10 raised by minus 15 is equal to Ni di positive concentration is S. OH negative concentration. OH negative concentration is coming out to be how much? It's coming out to be 0.1 raised power 2, right? Raised power 2. The equation is done. From here, you'll be getting the S value, right? And what is going to be S? S is going to be 2 into 10 raised power minus 15 divided by 10 raised power minus 2. The value comes out to be 2 into 10 raised power minus 13. So this is basically the value of solubility. Is there any option like this? 2 into 10 raised power minus 13? Yes. Option D is the one which is the answer of the question, right? Right, people? Okay, let's move on to one more then. the molar solubility of CaF2 in 0.1 molar NaF. Similar type of question, guys, similar type of question, right? Okay, Ksp of CaF2 is given. Okay, so first of all, remember CaF2, its Ksp is given, so it's going to remain in equilibrium with its ions. Its ions are Ca di positive aqueous plus 2 times F negative aqueous, right? Now let's assume its solubility is S, this is going to be S, this is going to be 2S, right? In the same container where CaF2 is in equilibrium with its ions, in the same container, I'm introducing NaF. NaF is a strong electrolyte, it would have got dissociated as Na positive plus F negative, right? Now people, what is the concentration of NaF that's given to me? 0.1. So this would have been at time t is equal to 0, this would have been 0.1, this would have been 0, this would have been 0. Now it's a strong electrolyte, it would have got completely dissociated, this will be 0, this will be 0.1, this will be 0.1. Now people, in the same container, we have got a weak electrolyte and a strong electrolyte, both are having one ion in common. What is that ion? That is F negative, right? So common ion effect is going to operate. Due to the common ion effect, what is going to happen? Solubility of this weak electrolyte will decrease, and I must say solubility of the weak electrolyte, let's assume it's coming out to be less than 0.05. That means the resulting F negative concentration, which is supposed to be 2S plus 0.1. So instead of 2S plus 0.1, I can only write 0.1. I can do the neglection. I can neglect solubility because I'm assuming solubility of this weak electrolyte has suppressed, right, due to common ion effect, and it has come out to be less than 0.05. That's why I've neglected it, right? So what do I need to calculate? I'll be writing the expression for Ksp. Expression for Ksp is going to be concentration of Ca di positive, that's S, multiplied by concentration of F negative, that's 0.1 raised power 2. Okay, Ksp value is given to us as 5.3 into 10 raised power minus 11. 5.3 into 10 raised power minus 11 is equal to S divided by 10 raised power minus 2. It's going to come as 5.3 into 10 raised power minus 9. Right? So option D is the one which is the correct answer of this question, right? Right, people? Exactly, Karthik, you are perfectly right. So this is one more similar type of question. I'm not going to do it. You guys are going to do it on your own, right? It's a very simple question. BaSO4, you'll be writing its Ksp. Get the value of Ksp, that's S square. S is given to us, right? You can do this question. It was a very simpler one, okay? Even this is a simpler one question. Even this is a simpler one, guys. So just remember how to dissociate it. We have got AgC2O4, right? It would have got dissociated as 2 times Ag positive plus C2O4 di negative, right? The solubility is S. Its concentration is going to be 2S. This is going to be S. Now you can write the Ksp expression. Ksp expression is going to be 2x square. That means 4x square multiplied by S, which comes out to be 4S cube. What do I need to calculate? Solubility product, right? So 4 times S cube, right? 4 times S cube. So 4 multiplied by S. S value. Okay, what am I given with? Concentration of Ag positive. Okay, concentration of Ag positive is given. Wait, just a second. Concentration of Ag positive is given to us. Concentration of Ag positive, which we got to know is equal to 2S. Its value is exactly given to us as 2.2 into 10 raised power minus 4. 2.2 into 10 raised power minus 4. So from here, you'll be getting the solubility as 1.1 into 10 raised power minus 4. This is the solubility, right? So Ksp will be 4 multiplied by 1.1 into 10 raised power minus 4 ka cube. Solid. Get the value of Ksp. That's it, right? Right, people? Clear to everyone? Yeah? I'm sure it's clear to everyone, right? So option C is the one which is the answer of the question. One more question we have, again the similar type of question, but there is only one thing needed over here. pH of the saturated solution of BaOH whole twice. We have got a saturated solution of BaOH whole twice, right? This will be in equilibrium with its ions, and its ions are Ba di positive plus 2 times OH negative aqueous, right? Let's say its solubility is S, this is going to be S, this is going to be 2 times S. That's something which you all must be doing. Well, people, pH of BaOH whole twice is given to us as 12, right? pH is given to us as 12. If pH is given to us as 12, that means OH, okay, wait, this is pH. If pH is given to us as 12, that means POH is going to be 14 minus 12, that means 2. That means OH negative concentration is going to be 10 raised power minus 2, correct? OH negative concentration is equal to 2S, that means 2S is equal to 10 raised power minus 2, that means S is equal to 0.5 into 10 raised power minus 2, or you can say S is equal to 5 into 10 raised power minus 3 molar. This is S which I got. What do I need to calculate? I need to calculate Ksp. So Ksp is going to be equal to concentration of Ba di positive, that's S, multiplied by concentration of OH negative raised power 2. That means 2s cube. So the value, 2s square. So the value is going to be 4 times s cube. So 4 multiplied by s is 5 into 10 raised power minus 3 cube. You can solve it, get the value of Ksp from here. The equation is done and dusted, right? Right, people? So option B is the one which is the answer of the question. Okay, we have got one more question, right? And this is again the similar pattern of question, people. Do solve it on your own and do let me know its answer in the comment section. So this was the last question of the tonight's session. I'm sure your equilibrium chapter would have got completely revised, yeah? Okay. I'm sure your equilibrium chapter would have got completely revised, guys, yeah? Do let me know in the comment section which chapter do you want the next, right? Okay, and the ones who have not joined into the NEET 2021 crash course, do. What happened, Arshad? What happened? Well, you guys can join me at 10:30 on Vedantu J English channel as well. I'll be conducting one mock test there, right? No, it's not going to be a mock test. It's basically previous year asked questions from the chapter S block elements and coordination chemistry. You can join in. You can join in, people, okay? So if you have not joined into the NEET 2021 crash course, which is there on the actual Vedantu platform, do get enrolled in this as soon as possible. This is the best and the last option for you guys to shoot up your rank. And let me show you exactly how to get enrolled in this one. This is the video which you guys are currently watching, right? You need to drag this video a little down. You need to drag this video a little down. You need to click on this show more. After clicking on this show more, there'll be a lot of links. Get NEET 2021 crash course. Click on this link. And after clicking on this link, you need to click on this buy now. After clicking on this buy now, if you are using the code WSNET, you'll be getting some 55% off, and you're just getting this crash course for 4,500 bucks. Okay, in this crash course, your physics, chemistry, biology, whole syllabus will be getting revised in these couple of days, right? And at the same time, there'll be mock tests, there'll be assignments given to you, there'll be test series at the same time, right? So do enroll in this. It's going to be highly beneficial, right? And the ones who have not liked the video yet, people, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Well, people, it was nice meeting you. I'll see you guys again at 10:30 p.m. on Vedantu J English channel. Till then, you guys can take care, right? You guys can have some dinner. I'll have dinner too. Yeah, I'll see you exactly at 10:30 p.m. tonight. Bye-bye, guys. Take care.